Welcome back. Today we're going to be covering a projectile motion question from high school physics. So the question says you throw a stone horizontally at a speed of 5 meters per second from the top of a cliff that is 78.4 meters high. We throw a stone horizontally and you're standing on top of a cliff. Now let's assume from the point that the rock is thrown at to the bottom is 78.4 meters high. Even though the cliff might be here and you're throwing it from up here, there is a little bit of a space, but we're just going to assume that from where the rock is thrown to the ground is 78.4 meters. So they gave us a speed of 5 meters per second, so that's our initial velocity. How long does it take the stone to reach the bottom of the cliff? When they say how long, they are asking for time. And we want the time it takes that stone to hit the ground. Now with projectile motion, you will have to look at the 5 kinematics equations, which is usually covered in the previous unit before you learn projectile motion. In projectile motion, we split these up into the x and y directions. The way you want to label your variables as well need to be either x or y. So I always like to make a table for this. Let's say x direction, y direction. We have velocity 1 or v1 or v initial. We have velocity 2 or v final, we'll say vi, vf. We have distance, we have acceleration, and all of these can be in the x or the y direction. And then we have time, which is universal for both. So time is not going to have just a time in the x direction or time in the y direction. It relates both together because it's the same number. And now let's add in the information we have. We have the initial velocity is 5 meters per second. Because it's thrown only horizontally, remember the x direction is horizontal, the y direction is vertical, and let's say up is positive and to the right is positive, so we define an axis. So this is going to the right 5 meters per second. We're going to say the x direction, initial velocity, is 5. The y direction is going to be 0 because the rock is not traveling at an angle, so it doesn't have both x and y components, and it's not going straight up. If it was straight up, it would only have a y component and 0 for the x. So it does say how long does it take the stone to reach the bottom of the cliff. It doesn't say that the stone has come to rest at the bottom of the cliff. Usually you would see the words the stone comes to rest or the object comes to rest. If you don't see that, you should assume that the final velocity is just a second before it hits the ground. So you can't just assume that this is 0. We don't know what this is. We can just leave it. Next, we know from the top to the bottom, vertically, it's a distance of 78.4 meters. This is distance in the y direction. In projectile motion, acceleration is always 0 in the x direction and negative 9.8 meters per second squared in the y direction. It is negative because it's Earth's gravitational constant that's pulling you downwards at this acceleration. So it really depends how you define your axes. If you have said that down is positive, then this number would be positive. The only reason this is negative is because I have defined the upwards direction as positive. So anything pointing downwards would be negative. These are always going to be the same. If you don't know anything else, at least you can always fill out the acceleration. And we are looking for time. It's going to be the same for both, whether it's x or y. The trick with these questions and kinematics equations in general, usually you want something where you are given 3 variables, at least, and 1 variable is unknown that you're looking for. In our case, we don't care about VF at all, so we can just take that out of the picture. But we do know 3 variables, and we're looking for 1. Now, specifically because projectile motion is split up in the x and the y direction, you can choose which column you want to look at. We have more information in the y direction. We have 3 variables instead of just the 2 given. So we can just use that. Now, because we don't have any information about final velocity and we're not looking for it, let's look at the equation that does not have VF. That's this one. We're going to take this equation and plug all our variables in only for the y direction. So let's see how we're going to rewrite this. There's a lot of symbols here that I'm going to take out just to make it easier. The arrow just means that a variable is a vector, so it has a direction, which means we would put a positive or a negative depending on the direction. The AV here just means it's average acceleration. The numbers we already have for acceleration are accounting for that, so you don't really have to worry about this. And the triangles just mean the change in that variable, which we've already accounted for in our numbers as well. So we can actually just keep it a little simpler and write it like this. And now because we chose the y direction equation, you're going to put a little y next to every variable except time. Time does not consider x or y direction, so we leave that as it is. So we add this number equals v1 in the y direction, that was 0. So this whole term crosses out because 0 times t, even if we don't know what t is, 0 times anything is 0. And that gives us 1/2 negative 9.8 t squared. And we would just solve for t. So now let's multiply these two numbers together. We get negative 4.9 t squared. And to simplify equations, we divide both sides by negative 4.9, which is 16, equals to t squared. And now you square root both sides, and you should get t equals 4. And the unit is seconds. So it should take 4 seconds for the rock to reach the ground. And we can actually go back and now plug that into our table. Now the question says, how far from the base of the cliff does the stone hit the ground? Now that would be this horizontal distance, that is dx. And what we can do now, because we are looking for a variable in the x direction, let's use the x column. We still don't have anything to do with VF, so we can use the exact same equation without VF that we used earlier. I'm going to copy the same equation as before, but now change all the y's into x's. So we had dx equals v1 xt plus 1/2 axt squared. The acceleration in the x direction is 0, so this entire term will cancel out. And we should have distance in the x direction, which is what we're looking for, equals v1, which is 5, in the x direction, times t, because now that 4 seconds we found from the y equations in part 1 is universal and can be used for the x direction as well. So that time is also 4. And the distance in the x direction should be 20 meters. So the ball has traveled a total horizontal distance of 20 meters. And part C says, what are the horizontal and vertical components of the stone's velocity just before it hits the ground? Well, this is where we do want to find VF, because it says velocity just before it hits the ground, which means VF. And we have found everything else now. We know that this is 20, and the only variables we don't know are VF. So now we can use the x equation to get the x component of the final velocity and the y equation to get the y component. The question is asking for the horizontal and vertical components. So the horizontal component is x and the vertical component is y. So now let's go back here. We can really pick any of the equations. We just want to pick an equation that has final velocity in it. So not this one. Let's use this one, and we'll use the x and the y direction both. So we have dy and dx. Because these equations will not put the x and y for you, you have to split it up yourself. And now we just plug the numbers in. We know the distance in the x direction was 20, and this was negative 78.4. We know that the time was 4, and v1y was 0, v1x was 5. Now to simplify these, we're going to move over anything that's multiplied like the 4's and divide them on the other side of the equal sign. Anything that's divided like the 2's will be multiplied on the other side. So we would have 78.4 divided by 4 times 2, and 20 divided by 4 times 2. Multiplying everything through, you end up getting 10 equals VF in the x direction plus 5. If you subtract this, you get the x component of velocity is 5 meters per second. Now the y component of velocity, you get negative 39.2 meters per second. And these would be the final answers. This also makes sense because if you look at the trajectory of the object, as it's going downwards, there is some component in the y direction and some component in the x direction that makes up this diagonal line. A part of it's going down and a part of it is going to the right. So these are the two components that make up that final velocity. And that's all for this lesson. Thank you for watching.